This video is on radicals and radical functions. So, what is a radical? If we have a square root of some number, the cube root, the fourth root, they're all radicals. And these are merely x raised 1 over 2, x raised 1 over 3, and x raised 1 over 4, and so forth. I would mention this again later on. By default, if nothing is specified over here, it always implies a 2. So here we want to find the square root of each of those numbers. So square root of 49, I could write 49 as a perfect square, which is 7 squared. So that would be 7 squared raised to the power of 1 over 2. And we multiply those two terms, which would give us 7 raised 2 over 2, which is 7. But keep in mind, anytime we take a square root, we put plus or minus, because it could either be positive 7 or it can be negative 7. So we could extend the same idea to other radicals, but typically it comes into play when we have the square root. So don't forget to specify plus or minus when we have square roots. So using the same logic here, we could write 25 as 5 squared over 4 squared, which is simply 5 over 4 squared. The root and the square would sort of go away. I call it sort of going away because mathematically that is not the right term to use, but it's easier to remember that the root and that would disappear, leaving us with an answer of plus or minus 5 over 4. So if the negative is front of the root, 4 is simply 2 squared, the root and the square would go away. Keep in mind, it's not the formal phrase to use, but I'm using it so that we can understand this easily. So the negative is in front of the root. We're going to leave it as is. So minus plus or minus 2, negative of plus or minus 2 is still plus or minus 2. In a similar manner, 0.81, I could write it as 0.9 squared. The root and the square would go away, leaving us with simply plus or minus 0.9. Here we have an expression in part E. So first our job is to write it as a perfect square. So 9 is 3 squared, and x raised 10, I could write it as x raised 5 squared. Now I could combine those two terms, because even though they have different bases, the power is still 2, so we can combine it as 3x raised 5 squared. The root and the square would go away, so we would have plus or minus 3x raised 5. Next example, we simply have negative square root of 25. The negative is in front of the root, so we leave it as is. We know 25 is a perfect square, so it would be 5 squared, and the root and the square sort of go away. And leaving us with negative of plus or minus 5, but negative of plus or minus 5 is simply plus or minus 5. And lastly, we have square root of a negative number. You have to know the difference between part F and part G. In part F, the negative is in front of the radical expression. In part G, it is inside the radical. So anytime you take the square root of a negative number, you will not get a real number as an answer. So the answer here is it is not a real number. Rather, it is a complex number, and we will talk about it later. So just like with square roots, we wrote the term that is inside the radical as a perfect square. So now when we have a cube root, we want to write the number inside the radical as a perfect cube. So what do I mean by that? We could write 27 as 3 raised to the power of 3. The reason being 3 times 3 times 3 is 27. And just like with square roots, the third root and the third power would sort of go away. Again, I'm doing this, or I'm saying this so that we can understand this properly or easily, but that is not the proper mathematical reason. The proper reason is that cube root of 3 cubed is 3 cubed raised 1 over 3. When you multiply, we have multiply the powers. We have 3 raised 3 over 3, which is 3 raised 1. You get 3. To avoid all of that jargon, we can simply go with the idea that the cube root and the third power would go away. And keep in mind, the fourth root and the fourth power will just go away in a radical expression. Fifth root and the fifth power would go away in a radical expression, and so on. So the answer here is 3. When we take the cube root, though, the answer is not plus or minus 3. That only applies to a square root. So now we have cube root of negative 125. The answer is not, or we cannot say that the answer is not a real number. The reason being the root here is cube root, not square root. You can take the cube root of a negative number. For instance, I could write negative 125 as negative 5 raised 3, and the cube root and the third power would sort of go away, giving us simply negative 5. Again, it is not plus or minus negative 5, it is simply negative 5. In part C, our objective is to write the number inside here, inside the radical, as a power of 3. Why is that? We are trying to find the cube root. So 8 can be written as 2 cubed, and 125 can be written as 5 cubed. And since the powers here are identical, I can combine them and write it as 2 over 5 raised 3. And now those two sort of go away, leaving us with 2 over 5. Lastly, we have cube roots of negative 8x to the power of 9. Our objective is to write the term that is inside the radical in powers of 3, so that we can simply cancel with the root. So I could write negative 1 as negative 1 cubed, because negative 1 times negative 1 times negative 1 is negative 1. And that is simply negative 1 cubed. So I could write 8 as 2 cubed, and I could write x raised 9 as x cubed raised 3. All of these terms inside the radical have identical powers, so I can combine them and write it as -1 times 2 times x cubed raised 3. The root and the cube sort of goes away, leaving us with -1 times 2 times x cubed, so the answer is -2x cubed. We are going to move on to higher order radical expressions, in the sense we're going to go beyond cube root and the square root. So the key to solving these problems is to look at the radical expression itself. Here, the root is the 6th root. So we would have to write the term that is inside in powers of 6. We know 64 is simply 2 raised to the power of 6. So those two would sort of cancel each other, and we would have 2. But note that 6 here is even. Since it is even, we're just going to throw in plus or minus 2. If it is odd, we're not going to put plus or minus. It only applies for an even root. So we want to write -32 in powers of 5, because the radical here is the 5th root. I could write -1 as -1 raised 5, and 32 as 2 raised 5. Those two terms have common power, so we can write it as -1 times 2, this is times, not -1.2, raised 5, and those two sort of go away, leaving us with -1 times 2, which is -2. Here, what we have is an even root. So since we have an even root and we have a negative number inside the root, the answer here is that it is not a real number. So typically when we have even roots and negative numbers, we are going to end up getting an answer that is not a real number. So you could always verify this with your calculator. For instance, I could put -16 and raise it to the power of 4. Excuse me, it's 1/4, because we're trying to find the 4th root. And enter, we end up getting an error, and if you closely observe the error, it says non-real answer. So we cannot take even roots of negative numbers. So 1/6, same thing. You could do 1/8, you would get the same thing. So any even root of a negative number is not a real number. That's one takeaway. The other is anytime you have even root, you can put the answer as plus or minus. And if you have an odd root, you just have one answer. And keep in mind, we can't take the odd root of a negative number. The root here is simply the radical. So we can use the same idea and we can extend it to expressions and complex expressions, complex in the sense, expressions that involve x's and y's and a's and b's. So that's what I'm going to show you now. So what we have is -4 and we have a square, and the square root and the square would sort of go away, so the answer is simply -4. Here we have stated we're taking the square root of -4 explicitly, so the answer is simply -4. So note, there is no plus or minus because we are taking the square root of -4 explicitly. If this were to be 16, square root of 16, the answer would have been plus or minus 4. So in the next example, we had the fourth root of x minus 2 raised 4. So the root and the fourth power would sort of go away. We simply have x minus 2. Again, it is simply x minus 2 because we are taking the root of x minus 2 raised 4 explicitly. And the next case is similar. We take the fifth root of 2x minus 7 raised 5. Those two sort of go away. The answer is 2x minus 7. So in the last part, we have 25, which is 5 squared, times x squared. We can combine the two and write it as 5x squared. Keep in mind that is the same as saying -5x squared. So in this case, plus or minus is important because those two would go away, those two would go away. So the answer could either be positive 5x or negative 5x, which would imply plus or minus 5x. So if the negative is explicitly stated inside a square root, such as in parts A and B, then we don't put the plus or minus sign. So keep that in mind. So we want to graph the square root and cube root of functions. Typically, we can simply do this using a calculator. So we just have to be careful with the domain of the function. So I'll show you how to do this using the calculator. Here we have two functions, square root of x plus 2 and cube root of x minus 1. We want to find each function value. So in the first part, we have to find f of 7, which would be square root of 7 plus 2. 7 plus 2 is 9. Square root of 9, I could rewrite 9 as 3 squared, but it could also equal to -3 squared, so the answer is plus or minus 3. Reason being, those two sort of go away, those two sort of go away, we end up getting plus or minus 3. So we have square root of 0 plus 2, which would simply be the square root of 2. And we can't put plus or minus here because we did not explicitly state the square, so plus or minus square root of 2. G of 9, we plug in 9 inside the function, cube root of 9 minus 1. 9 minus 1 is 8. We could write 8 as 2 cubed. The cube root and the third power would go away. We end up getting an answer of 2 and no plus or minus here. And in the next case, we have cube root of 10 minus 1, which is cube root of 9. And we cannot simplify this any further because 9 is not a perfect cube. So in a case like this, we have to make use of the calculator to find the cube root of 9. For instance, in your calculator, you could simply do 9 raised 1 over 3 because it's a root, so the answer is approximately 2.08. So we want to graph y equals square root of x. So x cannot have any negative numbers because square root of a negative number is not a real number. So the smallest value that you can plug in for x is 0. If you plug in 0 for x, you get y as 0. For 1 for x, you get y as 1, and so forth. And if you look at the graph, it's going to go like that. So I can graph this using the calculator. So y equals square root of x and enter and graph. And you can see the graph looks like the graph that I drew. So you can also note that the graph doesn't exist for negative values. The reason being we cannot take the square root of a negative number because if you take the square root of a negative number, you would get an imaginary number. So what is the domain? The domain here is the set of all x values for which the function exists. So that set of x values starts at 0 and goes all the way up to infinity. So the domain here is 0 included all the way up to infinity. The range is all the values over here, so it would be 0 all the way up to positive infinity. So we can graph other functions also in the calculator. For instance, we could graph the cube root and the cube root of x in terms of a graph would look very much like the square root of x on the positive side. But keep in mind, we can plug in negative values inside the cube root. So I'm going to show you how to graph that. So y equals, we have to change the square root to a cube root. So x cube root would mean the power of 1 over 3 and graph. And you can see on the right hand side, as I mentioned, the curve sort of looks like the square root of x. Not exactly, but something similar. So it sort of goes like that. But on the negative side, it has values of that sort, which we do not have with the square root. So in this case, the domain is defined for all x values, so all the way up to negative infinity, all the way up to positive infinity. So the domain here would be all real numbers. The range is also negative infinity to positive infinity, because we have values along the y-axis on the positive side and the negative side, so the range is negative infinity to positive infinity.